For this presentation, I'm going to be using this steel bar to represent a resistor. Now, most of you would know that steel will conduct electricity, but it's not as good as copper as a conductor. So we know that it will conduct, but it does offer some resistance. So I'm going to use it to represent a resistor. The amount of resistance that the bar offers depends on its cross-sectional area, which I've just highlighted in blue, and how long it is, as indicated by the red line here. So if I was to put two of these resistors in series, i.e. one after the other, the current would still have to flow through the cross-sectional area, but it would have to travel twice as far. And so we can see that the resistance to current flow will be doubled. Now if I rearrange these resistors and put them side by side as shown here in this picture, you can see that the current can flow through both of them. Half will go through one of them and the other half of the current will flow through the other resistor. These resistors are said to be wired in parallel. Now you can see that the cross-sectional area has doubled, but the distance the current has to travel remains the same. So, as I say, in this image, the two resistors are connected in parallel. Now, assuming that they offer equal resistance, in other words, they're both exactly the same, both identical, my current would flow in at this point, and when it gets to here, it would divide, and because the resistors offer equal resistance, half would flow through this resistor, and the other half would flow through this resistor. So in terms of resistance, adding resistors in parallel has given my current two pathways to flow through. So it's made it easier to flow. So adding resistors in this case has made it half as difficult to flow. So we've reduced or made the resistance half of what it would have been if there was only one resistor. Let's compare that or consider conductivity. In terms of conductivity, we've now allowed or created two pathways for the current to flow through. So we've increased the conductivity by a factor of 2. We've made it 2 times as great. The point is that these two factors are proportional. Let's just say if I was to add another resistor here, now I've created, and assuming that all three of these resistors offer an equal amount of resistance, then I've now created 3 pathways for my current to flow through. My resistance would now be 1/3 of what it would be if I only had one resistor. All right, so I've reduced the resistance, but I now have 3 pathways for the current to flow through. So conductivity is now 3 times as great as it was. Okay, so with 2 resistors, the resistance is effectively halved, but the conductivity was doubled. And with 3 resistors, the resistance is 1/3 of what it would have been if there was only one resistor, and the conductivity is now 3 times as great. Hopefully you will have noticed that there is a relationship between any decrease in resistance and any increase in conductivity. So as one reduces, one increases, and they are inversely proportionate to each other. In order to be able to calculate the resistance of a parallel circuit, we need to understand what reciprocal numbers are. Now, that's a mathematical term, and every number apart from 0 has a reciprocal number. A reciprocal number is the number that we need to multiply our original number by to equal 1. That's a long-winded way of saying it. But let's just consider a number. I'm going to start with the number 2. What do I need to multiply 2 by to equal 1? All right, in other words, the reciprocal number of 2 is the number that I need to multiply 2 by to get 1. So in this case, I'm going to give you the answer. 2 multiplied by a half, that's just the time sign in the middle just means of. So half of 2 is 1. So the reciprocal number of 2 is a half. Let's just give you another example. All right, let's erase that. Let's try to find the reciprocal number of 3. So the question is, what do I need to multiply 3 by to find, or to get 1? Well, the answer will be 3 multiplied by 1/3. In other words, what is 1/3 of 3? It's 1. So the reciprocal of 3 is 1/3. Okay, just going to take that a stage further. Let's get rid of this. Something else that is useful to understand is when I write the number 3, if I show that as 3 over 1, all right, what I'm actually writing is 3 divided by 1. So 3 divided by 1 is 3. So any number over 1 will always be whatever that number is. It's just a different way of presenting the numbers. Okay, so taking that a stage further, we can say 3 is exactly the same as 3 over 1. And the reciprocal of 3, let's draw that like that, the reciprocal of 3 is 1/3, 1 over 3. Now hopefully you can see that these numbers are also proportional. If we take our starting point as 1, one of the numbers is 3 times smaller than 1 and the other number is 3 times greater than 1. And we can see that they are inversely proportional to each other. So in my example of a parallel circuit here, where I've got identical resistors, the resistance is halved, but the conductivity is doubled. So hopefully you can see that resistance and conductivity are inversely proportional to each other. They are the reciprocal of each other. So here we have an example of an Ohm's law problem where what we need to do is calculate the current flowing through this circuit. Now to do that, we're going to start with drawing our Ohm's law triangle. Let's fill in the information that we do have. Now we know that we've got a 15-volt supply and we are trying to find the current flowing through this circuit. Now in order to calculate the total current, we need to know the total resistance of the circuit. If the resistances were in series, all we'd have to do is add the total value of the resistance, but they're not, they're in parallel. But what we can do is find the total conductivity of our circuit. Conductivity is inversely proportional to resistance and can be shown as 1 divided by the total resistance, which in turn would be equal to 1 divided by R1 plus 1 divided by R2. So just to reiterate, what we are showing here is that the total conductivity of the circuit is equal to the conductivity through resistor 1 plus the conductivity through resistor 2. So we now know that the total conductivity, which is equal to 1 over RT, is equal to 2 over 10. So I'm just going to create a bit of space up here and erase this. We also know that the reciprocal of conductivity is resistance. So if we find the reciprocal of 2 over 10, we will find the total resistance. So once again, I'm just going to clear some space down here. We know that the reciprocal of a number is whatever I need to multiply that number by to equal 1. So if I take 1 and divide it by our number, I will find the reciprocal of that number, which in our case is 1 divided by 2 over 10, which will show us the total resistance. Now 2 over 10, or 2/10, can be written as a digital number as 0.2. So 1 divided by 0.2 will equal our total resistance. So that's 1 divided by 0.2 equals 5. So our total resistance is 5 ohms. So now we can go back to our Ohm's law triangle and write down the total resistance for the circuit, and we can now calculate the current, which is 15 volts divided by 5 ohms, which means that we have a total current of 3 amps flowing through this circuit. So to summarise, I'm just going to clear this part of the board. In summary, to find the total resistance of a parallel circuit, or RT, we need to find the reciprocal of the total conductivity of that circuit, which is 1 over R1 plus 1 over R2 and so on, for however many branches of resistance there are in the circuit.